Hey gang, so this is a video to help you with the unit circle. And I'm going to actually show you what the point of the unit circle is, finally. The point is to use it to evaluate things. So if someone wants to know what the sine of pi over 6 is, that's a number. And I use the unit circle to figure that out, and I'll show you that in just a sec. This is something that we're going to use off and on throughout the rest of the year in our trigonometry units. It's something that you're going to use in Calculus AB, and it's something that I use with my students in Calculus BC. And we don't have time to stop and think about what sine of pi over 6 is. Eventually, we just start to know it. So that's what the unit circle for, is to evaluate, because eventually you're going to be able to go, oh, the sine of pi over 6 is 1/2. And I'll show you how I was able to do that so quickly without even drawing the unit circle. Okay, a lot of it just takes practice. So here's the first thing that you need to know when we're looking at on the unit circle. We've talked about this before, how the radius is a hypotenuse, and to get to this coordinate point, x, y, I'm going over x and up y to get to that point, okay? And we know our radius is 1. What I'm about to show you is actually super duper important for when you get to calculus when you talk about polar coordinate points, okay? So it's one big circle of information. It just keeps kind of like tying itself into something else. So what I'm going to do is go back to writing down my ratios: sine, cosine, tangent, cosecant, secant, cotangent. Okay, you should have these memorized because we had already talked about doing this with basic Pythagorean theorem problems. And I kind of just made sure that you had this pattern down because I knew that you would need it for this moment in time. So sine, if I'm answering these ratios based on this triangle, sine is opposite over hypotenuse. Well, hypotenuse is 1, so I'm not going to write that down. Cosine is adjacent over hypotenuse. Tangent opposite over adjacent. So yx, yx. So just using basic trig to figure that out. So SOHCAHTOA. And then cosecant is the reciprocal. So 1 over y, 1 over x, x over y. This you need to have memorized. Okay? And if you can't remember it, then you're going to have to derive it from this triangle. Okay? So, looking at the unit circle, it's made up of terminal points that have x and y. So what we need to know is that cosine is x and sine is y. That's what we just figured out. So let me start with some really easy evaluation problems, and then we'll kind of work our way up, and I'll show you I can just get a little bit more complicated. But if you know the unit circle, you can do these problems. They're not that bad. All right. So let's say I'm going to do the sine of pi over 4. So what I do is I look on the unit circle and I find pi over 4, and I look at the y value because that is what sine is. And that's my answer. I'm done. Okay? Let's do a few more. Let's say I'm doing sine of negative pi over 4. Okay? So what I'm going to do is, instead of going 45 degrees this direction, I'm going to go 45 degrees this direction. And I'm going to look at my y value, and that's negative radical 2 over 2. That's kind of a neat thing to observe for just a sec, and it's true every time with sine. If you look at any of these for sine, your y value, it's always going to be the opposite. So if I'm doing sine of 2 pi over 3, 2 pi over 3 is radical 3 over 2. Let's take a second and look at sine of negative 2 pi over 3. So again, instead of going in this direction, I'm going to go the opposite direction. And it just makes your answer negative. So that's really true anytime. If you're doing sine of an angle and then looking at sine of the negative of that angle, it's just going to make the answer negative. But that's not true for cosine. It's only true for sine. Okay? Let's do some more. Let's talk about cosine. So, cosine of 7 pi over 6. All right, so I'm going to look at my unit circle. I know cosine is x. Here's 7 pi over 6. X is right there. That's the answer. Let's talk about cosine of pi over 2. Here's pi over 2. Cosine is x. The answer is 0. Pretty simple. So where does it start to get a little tricky? Well, with your coterminal angles. And this is why I went over those patterns with counting. How all the 4s you're adding 2 every time. With the 6s you're adding 4, 2, 4, 2. And with the 60s, how I'm adding 1, 2, 1, 2. But you could also, just add or subtract 2 pi or 360 to get coterminal angles. So let's say I'm doing something like, oh gosh, cosine of 17 pi over 6. All right, so 17 pi over 6 is not on the unit circle. I'm going to use the counting tricks because I really like this. I think that's the easiest way, but I'll show you another way too. You can kind of pick. Okay, so for pi over 6, the counting pattern is add 4, add 2, add 4, add 2. So if I add 2 to 11, I'm now at 13. If I add 4 to that, I'm now at 17. So this is actually the angle I'm looking at. And the cosine value is x. So that's my answer. That's one option. That's why I showed you those neat counting patterns. Now the other option would be just to do the math, as they say. So if I take 17 pi over 6, you're like, oh man, that's not on the unit circle. It's too big. It's over 2 pi. So we can subtract a 2 pi, get a least common denominator. And that's another way that you can figure out it's 5 pi over 6 and go from there. So you have some options. You can pick. If you like the counting patterns, great. If you don't and you can subtract fractions, that's fine too. I've also seen some people convert to degrees, then subtract, and then convert it back to radians. It seems like a lot of work to me, but if that's what makes sense to you, then do that. Let's look at some tangent problems. This isn't any harder, except for the fact that you need to know how to divide fractions, okay? So tangent is y over x, and let's say I'm doing tangent of 3 pi over 2. So here's 3 pi over 2. I'm going to take the y value and divide by x. Negative 1 over 0. That's undefined. I just threw my head. Don't worry, I can do that. Okay, so undefined. If you have 0 over 1, like tangent of pi, 0 over negative 1, that's just 0. So that's like basic Algebra 1 stuff, but if you haven't thought about that kind of stuff in a while, make sure you know the difference between undefined and 0. Let's say I'm doing tangent of pi over 6. Okay, so I'm going to take the y value and divide by the x value. So 1/2 divided by radical 3 over 2. When you divide fractions, you flip and multiply. The 2's are going to cross cancel, so that leaves you with 1 over radical 3. We don't like to leave our answers like that, so I'm going to clean it up by rationalizing the denominator, and that gives me radical 3 over 3. All right, let's look at another tangent one. Let's do tangent of 13 pi over 4. Step 1, 13 pi over 4 is not on the unit circle, but I'm going to count once again because I know that the pattern for the 4's is just adding 2. So if I add 2 to 7, I get 9. Add 2, you get 11. add 2, you get 13. So I'm actually right here. So I'm going to be taking this y and dividing by this x. Is it really necessary for me to flip and multiply? No, because they're the exact same thing. And this is what's great about the pi over 4 family. Anytime you're doing tangent or cotangent, your answer should be 1 or negative 1. Okay? If I divided something divided by itself, you're going to get 1. So in this quadrant and in this quadrant, tangent and cotangent will be 1 at the pi over 4 family members. And then in these quadrants, you'll have negative 1. So those are really easy. And that's why, right off the top of my head, I know tangent pi over 4 is 1. I don't even have to look at the unit circle. And it's not because I'm that smart, it's because I just have it memorized, and you will too. The more you practice this, you're going to get the hang of it. It just kind of happens, okay? All right, let's look at some of our secants and cosecants and those operations, okay? So let's do secant of 3 pi. Okay. 3 pi isn't on here. But the ones that are like the whole numbers, 3 pi, 4 pi, whatever, it's so easy to count because here's 0, there's pi, 2 pi, 3 pi. And secant is 1 over the x. So if I do 1 divided by negative 1, I get negative 1. So I just do 1 divided by negative 1. Okay, let's have you guys try one like that. Let's do secant of 6 pi. Think about that for a sec. Okay, so 6 pi, if pi is over here, then all the odds will be on this side. All the evens will be on this side. So we're going to be over here. And 1 over 1 is 1. Okay? Now, what if I was doing cosecant? You're going to get some undefines. Okay, so be aware that that's a thing. Okay, so let me just do a few more problems with you. Let's do sine of 19 pi over 6 and cosine 17 pi over 3, secant of negative 5 pi over 4. And let's do 1 degrees, cosine of 495. All right, so let's work our way through these. And if you want to try them on your own, that would be great. Just pause it and play it when you're ready to see the answers and the explanations. Okay, so sine of 19 pi over 6. 19 pi over 6 isn't on this, so I can either subtract 2 pi until I get something that is on the unit circle, or I can count. I'm just going to do the counting patterns. So from 11 pi over 6, I would need to add 2, so that would be 13 pi over 6. Then I need to add 4, 17 pi over 6, add 2, you're here. So sine is the y value, so that's negative 1/2. All right, let's look at cosine 17 pi over 3. Also not on here, so I'm just going to count again from the 3's. So I need to add from here, I need to add 4. So that would be 9 pi over 3. 10 pi over 3, 14 pi over 3, or no, I'm not adding right, am I? How much are you adding? It goes 1. That's the great thing about these. You don't have to memorize the patterns. You can always just figure it out again. So it's 1, 2, 1, 2. Okay. So I should add 2. So that's 7 pi over 3. Add 1, 8 pi over 3. Add 2, 10. Add 1, 11. Add 2, 13. 14. 16, 17. Whew, all right, had to count quite a bit there. So then I'm going to look at the x value.